All right, here's a new thing. This one's really for the maths methods people. So I normally do videos for the further maths people, but this one's for math methods. And this is part 1. It gets a bit long. I've done quite a few examples just to show all the annoying little tricks that I have in there. For polynomial division, I'm going to show long division, a thing called synthetic division, which some people find easier, and calculator on your class pad, which is even easier. Okay, so polynomial division, we're going to take this big polynomial and divide it by this smaller polynomial in a couple of ways. First way we're going to try is called long division because it's long. And so we take our 3x cubed minus 7x squared minus 4x plus 12, and we're dividing it by x minus 2. And what we're going to try and do is try and get this first term here matching the first term here. And to do that, we're going to say, 3x cubed divided by x would be 3x squared, yeah? And so if we then take that 3x squared, multiply it by this whole thing, what you get is 3x cubed, and then the 3x squared times the minus 2x gets you minus 6x squared. Now, we then just take this part here and subtract this part here to get our new things. Now, obviously, the whole point was to cancel these out, so that's going to be 0. So we really only have to worry about this part here. So minus 7x squared minus negative 6x squared is actually minus x squared. Now, this has got 2 terms, so when we do division, we need 2 terms here. We've only got 1, so we're going to take this term and bring it down to here. So we get minus x squared minus 4x. Okay, I'm trying to neaten that up because that's bugging me. There we go, it's a bit better, slightly better. Now we've got to get this term here to match this term here. So minus x squared divided by x will get us actually minus x. So we can write now minus x. And so we're taking this minus x and multiplying it by this. Obviously that's going to get us this term, but then we're going to do this bit by this bit. So you get minus x squared, and minus x times minus 2, that's going to get you positive 2x. And then we take this part and subtract this part. These two will cancel out. And so minus 4 minus 2 is going to get us minus 6x. And again, we need 2 terms. So we take this term and bring it down to here to get us our second term. So we say plus 12. Now again, we've got to get this term and this term to match. And so minus 6x divided by x will get us minus 6. And so minus 6x and then the minus 6 times the minus 2 gets us positive 12. And we can see actually that everything here matches up. So when we subtract everything, we get 0. So our remainder equals 0. So what we're actually saying is that you can actually say that the x minus 2 is a factor of this because you had no remainder. Just imagine if you divided 21 by 7, you would get 3. So you know that 7 is a factor of 21 because there's no remainder there. So we can just say that actually 3x cubed minus 7x squared minus 4x plus 12 does in fact equal 3x squared minus x minus 6 times by x minus 2. And I'll just prove that over here. And we're going to just do this. So I prefer this method rather than FOIL because FOIL only works for limited cases. I'm going to put my x and my minus 2 here. I've got my 3x squared minus x and minus 6. So 3, when I multiply this by this, I'll get my 3x cubed. Then x times minus x is minus x squared. X times minus 6 is minus 6x. Then I'm doing the next row, so 3x squared times the minus 2 gives me this point. So I get minus 6x squared, then plus 2x, and then plus 12. So you can see when using this grid system, it's a lot easier to see which terms you're doing and make sure you don't miss any. Here's my only cubed term, so that's 3x cubed. Then I've also got an minus x squared and a minus 6x squared, so I can say minus 7x squared. I've got a plus 2x and a minus 6x, so that gives me a total of minus 4x, and then I've just got that 12 left there, so I just get a plus 12. And that just is a way of expanding it and showing that actually x minus 2 is a factor. Also 3x squared minus x minus 6 is a factor. You could keep working through these things and dividing through by factors, but it's an important thing to note that when your remainder is 0, then this must be a factor of this whole big thing, just as this is actually also a factor at the top there. They're both factors. Now, using long division, we got it this way. I'm going to show you a thing called synthetic division. And I'll do it in purple. What the heck, why not? There's a difference. Now, first of all, we're going to just do this shape like so. And we're going to take the coefficients here. These are all these numbers, and just put those in. We ignore all the x's. So this is going to be 3, minus 7, minus 4, and 12. Now, we've got this thing x minus 2. What we're going to say is when you've got x minus 2, we're going to change that to 2. All right, so we take, I'm not going to go into too much detail, but this minus 2 is now going to become 2, and I'm writing this 2 here. All right, now synthetic division can sometimes look a bit quicker. So the first thing you do is say, take that 3 and put it down. Then we take this 3 and multiply it by 2. I'm going to show it some arrows that goes here. So 3 times 2 is 6. Now we just add these two. Remember over here we were sort of subtracting, but we're going to add these two. So when we add these two, minus 7 plus 6, we get minus 1. Then I take this minus 1 and times it by the 2. So 2 times minus 1 is minus 2. I add them. I get minus 6. And then I've got to do one more. So I've got the minus 6 times the 2. So that goes up here. I get minus 12, and I add them, and I get 0. Now, we've only got one digit here. This one is going to be our remainder, and the rest of them are going to be our powers of x. So if you can imagine, this is x to the power 0, x to the power 1, x to the power 2. If it's longer, you have to go x3, 4, etc. So you end up with 3x squared minus x minus 6, and the remainder is 0, so we don't have to write anything about the remainder. Some people find that much quicker and easier. I'm going to go through a few more examples to show that sometimes it is and isn't, but stay tuned. Okay, so we got the answer of this. How do you do it in the calculator? You've got to go to action, transformation, fraction, prop frac. This is on the Casio ClassPad. I'm a Casio ClassPad teacher. And then what you do is you get this prop frac, you set up a fraction. I don't think I actually need to close that last bracket, but you can see we've got the 3x cubed. I've done it as 3x hat 3, that little hat symbol, which is shift 6, minus 7x squared, so minus 7x hat 2, minus 4x, there it is, plus 12, there we go. And then on the bottom, you put the divisor, which is x minus 2, to get your quotient, fancy word for the day. Quotient is the result of a division. Quotient. The same quotient in IQ. It's intelligence quotient. Famously, one student went to me and said, I can spell intelligence calculation. I'm like, yeah, calculations with a C. Anyway, you can see that the funny thing that they also do is they put a little dot there for the times. That's kind of like some countries do that. I had a Russian teacher who kept doing that to me and annoying the hell out of me. That's not 3.x squared, that's 3 times x squared, but the dot is just for the times. You don't have to do that when you're writing it out, okay? You don't need a Russian or a calculator, I hope. Okay, so we're going to do some more division both ways. This polynomial divided by this polynomial. Let's do long division first. So we've got 2x cubed minus 3x squared plus x minus 2, and we're dividing it by x minus 3. We've got to make this and this match. So to do that, you need 2x squared, because 2x squared times x, 2x cubed. Now the 2x squared has got to multiply the -3, so you end up with 2x cubed minus 6x squared. Then we do the subtraction, so this minus this, so you end up with -3 minus -6, which is actually 3x squared. We need an extra term, so we bring this term down to here. So we get plus x. Now we have to match this to this. So 3x squared divided by x will get you 3x. So we're going to say plus 3x. So we get 3x squared. And then the 3x has got to multiply the -3. So you get minus 9x. Then we take this and subtract this. So you get 1x minus -9, which is actually then plus 9. So it's 10x minus 2, because we're going to bring down the 2 to get a second term. We're dividing by 2 terms. We need 2 terms to do the division. We're going to make this 10x the same as the x. That's a simple one. That's just going to be plus 10. So you end up with 10x, and then you got minus 10 times minus 3 is minus 30. So do the subtraction and you get left with 28. And now this is your remainder. Your last one is your remainder. So your remainder equals 28. So we can't divide that because this doesn't have an x, whereas this does have an x. So that's your limit. So you can actually just write that as then saying, well, it's a positive 28, so it's plus the 28, and we're still trying to divide by x minus 3. So that 28 still needed to be divided by that. So this is not a factor. So let's do it in red. So this is not a factor because we had a remainder, not a factor, because we had a remainder. So let's have a go at this then using synthetic division. We should still get the same answer. Let's see how that works. So again, we draw a funny sort of big L shape, and we're going to take the coefficients of each of these. And so you get 2, -3, 1, -2. And we've got x minus 3. And all you got to do is when you've got x minus 3, so x minus 3, that's going to get us just 3. So we just take that last bit there and just flip the sign. Not going to go into details about that. It just does it because it works like the rest of synthetic division. There is a reason why it works, but you don't need to know that. So we just bring the 2 straight down. Then we do 2 times 3. That gets us 6. -3 plus 6 gets us positive 3. Then we do 3 times 3 is 9, so we get a 9. 1 plus 9 is 10. 3 times 10 gets us 30. Minus 2 plus 30 gets us 28. We're going to remember, if you've got 2 terms here, then your remainder is going to be 1 term. So that one's the remainder. And then that's going to be x to the power 0, x to the power 1, x to the power 2. So you get 2x squared plus 3x plus 10. And your remainder is plus 28, and you're still trying to divide by x minus 3. Which one's quicker? Up to you. Okay, now we're going to do this polynomial divided by this polynomial, and what you'll notice here is a little bit of a trick because we've got a cubed here, and then we've got a power 1 and a power 0. We haven't got the squared in there, and so you've got to just like have every single power in there. So I'll show you what I mean by that. So we're going to do our long division first, just to show the comparison. So we've got x cubed. We've got no x squared, so we've got still a squared symbol. It was missing in there because obviously 0x squared is 0, but we need to put it in there to make the whole thing work. Plus 3x minus 4, and we're dividing by x plus 1. We're going to make that match with that, so you're going to need x squared. So x squared gives you x cubed plus x squared because you're doing x squared times 1. And so then you do your subtraction. So you get nothing here, and then you'll get minus x squared there. but we've got two terms here, so we need to take this term and bring it down to give us a second term. And then we got to get that to match that, which is actually just minus x. So you end up with minus the minus x times this whole thing. To get here, we get minus x squared minus x. Do your subtraction. So this minus this, and you'll get 3 minus negative 1, which is actually addition then. So 4x, and we needed to bring down this minus 4 to give us our two terms. We then got to make the 4x match with the x. That means we've got to have a plus 4. So you end up with 4x plus 4. So when you're doing a subtraction, you actually end up with negative 8, and that's going to be your remainder equals that. And we know it's the remainder because this is 1 power less than that. That's x to the power 1. This is x to the power 0. We can't continue because we can't make that into the x thing. We didn't get 0, so this is not a factor of this. And so we're just going to then say minus, because we got that negative in the front there, and the 8 is still trying to be divided by x plus 1. All right, let's go synthetic division. So again, what we do is same thing. You've got the coefficients, but we still have to do that thing where we put the 0x squared in here. So our coefficients are actually 1, 0, 3, negative 4. We've got x plus 1, and we know that we take this bit here and we flip it to minus 1. So we can actually have minus 1 here. Bring the 1 down. 1 times minus 1 gets us minus 1. 0 plus minus 1 is minus 1. Minus 1 times minus 1 gets us 1. I'm going to keep putting the arrows in for the moment. You don't need to put all these arrows in. You can just do it. Then 3 plus 1 is 4. 4 times minus 1 gets us minus 4. Adding them gets us minus 8. I like synthetic division because I don't make such a mess of my negatives and get confused with them, because I'm just adding. That's the advantage of having that, flipping that to a negative, is it just becomes adding. So again, we can see that this is the remainder. The last one is the remainder. We only have one term for the remainder. We'll do other examples later with longer things, don't worry. And that's going to be x to the power 0, power 1, power 2. So that's why you get x squared minus x plus 4, and we're subtracting the 8 that still needs to be divided by x plus 1. And you can see we get the same answer. Now, we got this answer here from doing synthetic division, same as we got with long division, but you can see the calculator does it a little bit weird again. So we've got the x squared, we got the x squared, we got the minus x, we got the minus x, we got the plus 4. The plus 4 is put to the end. It just does the x, it does this one because it's got an x next. So it does the x squared, the negative x, and then the, well, x to the minus 1, I don't know, next term. So like if you're trying to fool your teacher that you actually did this by hand, make sure you put them in this order rather than this order, because that tells them if you did it in that order, you got the calculator order. But again, it's just that prop frac, whatever prop frac means. And that's how you get the answer.